I have to talk to you people about the geometric series के बारे में, okay? The geometric series. Now, as we have done in that arithmetic series, now you see that there is 1, comma 2, comma 4, comma 8, comma 16. So now this is a GP, and if I write it like 1 plus 2 plus 4 plus 8 plus 16, now this is going to be a geometric series. Okay, so we must know how to find the sum of any given number of terms in a geometric series. Acha, as it was the case in AP, that all the formulas of AP could be applied to the formulas of the arithmetic series. So similarly, we can apply that formula which was for the nth term, that an is ar is prime minus 1, onto this series situation as well. Okay, but there is a formula for the sum. The sum formula is the sum of the first n terms is a into 1 minus r raised to power n over 1 minus r. Or if you take a minus common from both numerator and denominator, the same formula can also be written as r raised to n minus 1 over r minus 1. Okay, so
Okay,
now
sir.
suppose this is the case and you want to find the sum of the first 10 terms, let's say you want to find S10. So this will be, now your A in this question, your A is 1, your R is 2, and your N is equal to 10. So the sum of the first 10 terms is going to be A. Now which formula should I use, this one or this one? That depends on the value of R. If your R is more than 1, you better use this formula. If R is less than 1, you must use this formula. That will save your time, okay? Otherwise, any of the formulas can be used if you're not worried about the time, okay? So S10 is going to be A, which is 1, into R raised to power, this is 2 raised to power 10 minus 1 over 2 minus 1. So this is 2 raised to power 10 minus 1. You can use your calculator to find the sum. Now suppose instead of this you have a sequence which is, let's say it is 10, comma 5, comma 2.5 and so on. And you want to find the sum of the first 5 terms, okay? So you better use this formula this time, because this time your R is going to be 5 over 10, which is half. Now this is less than 1. So to avoid that minus coming in this case, so we must use this formula. So S5 is going to be A into 1 minus half raised to power 5 over 1 minus half. And then you can simplify this to get to your answer. Now let's see what kind of questions do we have in the book. Okay,
Yes, sir.
so going back to the book here. Um, so look at this 8th question now. It says um, you have to find the sum of the first 8 terms in all these cases. Okay, so let's try that. Sum of the first, uh, I'll be doing one, like let me do the C part for you and then you can try the rest yourself. Okay, now 8C, change the color, 8C. Now this series is 1 minus 2 plus 4 minus 8 and so on. So your R is 1. What is, sorry, your A is 1. And what is your R here?
-2.
Yeah, that is minus 2. Okay. So we shall be using this formula. Sn is A into 1 minus R raised to power n over 1 minus R. Please do that. Try this. See what's the sum here. So this sum of the first 8 terms is going to be 1 into 1 minus minus 2 raised to power 8, okay, over 1 minus minus 2. So this is going to be
Minus 85.
1 minus 2 raised to power 8 over 3. So what is this, Vachok? Did someone find this?
Minus 85.
Minus 85. This is such a small number. It's 85. Okay. Are you sure this is minus 85?
Yes,
Okay,
sir.
this must be true then. Okay. Now please try the other, any two of the other 3 parts. Okay. Another question is that the first 4 terms of a GP, they are given. This is 0.5, there is 1, there is 2, there is 4. So we get 2 things from here. One is the A, which is 0.5, and then R, which is 1 over 0.5, that is equal to 2. So we have the R and we have the A. It says find the smallest number of terms. So we have to find N, okay? The smallest N, which will give sum greater than a million. So if Sn is greater than a million, so what is the smallest value of n? So this will become an inequality over here. So you know that the Sn is going to be a into r raised to power n minus 1 over r minus 1. I'll be using this formula this time because r is greater, okay, greater than 1. So this Sn would be this is going to be this is 0.5 into r is 2 raised to power n, and then you have minus 1 over, you have 2 minus 1, that is greater than a million. Okay, so this is this 2 minus 1 is 1.5. I'm writing this as half. So 2 raised to power n minus 1 over 2, that is greater than a million. Okay. Now this 2 raised to power n minus 1 is greater than 2 millions. And this 2 raised to power n is greater than 2 million and 1. Okay, I'm going to pause the video for a minute. Though this has to be done through the logarithms, but if you don't want to do that with the logarithm, then you will have to try hit and trial. Okay, you use your calculator up to the time that you get near closest to this 2 million and 1. Let's see, suppose you have something like this, 2 raised to power n, that is, let's say 64, okay? And you want to know that what power on 2 is going to give us 64. So you will keep on multiplying, like 2 into 2 into 2 into 2. So you will see that there will be a time when you will get that, like, I think 2 raised to power 8 is 64.
No, sir, 6. 2 raised to power 6 is 64.
6, oh yeah, 2 raised to power 6 is 64, okay? So now let's do that hit and trial and see what power on 2 is going to give us 2 million. Okay, let's see. 2 raised to power 20 gives me 2 raised to power 20 is giving me 1,048,576, and 2 raised to power 21 is giving me 2 raised to power 21 is giving me 2,097,152. So that means the minimum n has to be 21. That can give us a sum more than, oh, so this is 20, sorry. This is 20. No. I need this 2 millions. Yeah. So this is the information that I need here. So if this n is 21, that is the smallest n that can give you a sum more than 2 millions.